Hi there everybody. This video is about triangle and quadrilateral proofs. We've been working up to this lesson for quite a while. We started proving triangles were similar back in chapter 3. We started talking about triangles being congruent in chapter 6. And now we're going to have, at the end of this lesson, we're going to have a fully developed argument for why two triangles are congruent, or why two segments are congruent, or two angles are congruent, and a couple of different ways to organize that information. So that's where we're going. We've used a flowchart before, so we'll start with that. So there's some information that we're given here. We're given that BD bisects AC. So this segment BD bisects segment AC. Now, bisect is not a word that we have seen before, but that word bisect means cut in half. So BD, it bisects or cuts in half AC. That means these two segments right here are the same. We're also given that the measure of angle ADB, that's this one, and the measure of angle CDB, that's this one, are the same, and you see arcs there. I'll put these on there since we know those are the same too. And that's what we're given. And we're trying to prove that these two triangles are congruent. And that's the symbol for congruent right there. Triangle ABD and triangle CBD. That's what we're trying to prove. Okay, well, what else? We can't prove a triangle's congruent by side angle or angle side. We need three pieces of information usually. So what else can we figure out about this triangle? Well, we know that they share that side right there. So that has to be the same in both triangles. Now we've got three pieces of information. Now we have enough to say that whether the triangles are congruent or not. And here we have side, angle, side. So side, angle, side is going to be our plan. Now proofs, so let's side, angle, side. So our first side, let's say AD equals CD. There's one of our sides now. Now, how do we know that those two are the same? Well, that came from this statement over up here. So that came from the definition of bisect. And so that is the reason. We're going to put reasons for all of these statements that we make. Now, we've got to be able to justify all of them, not just the last one, but all of them. And so that is our justification for how we know that AD and DC or CD are the same. We were told that BD bisects or cuts in half AC. That means, that's the definition of bisect, tells us that those two have to be the same. So that's one of our sides. We got angle. So we got measure of angle, ADB equals measure of angle CDB. Oval around it. And how do we know that? Well, we were given that in the beginning. So our reasoning is given. Now our last pair of sides is right here. It's BD. So we'll say BD equals BD. And the reason we know those are the same is shared side. All right, now we didn't really, this statement right here you don't see in our proof yet, or you don't see in our flowchart yet, and it really should be there. Really, flowcharts, proofs in general, should start with the information that you're given. So I'm going to put another bubble up here. BD bisects AC. And we'll put an oval around. How do we know that's true? Because it's given. And we use that statement to draw that conclusion. So I'm going to put an arrow there. Now we've said side angle. We said side angle side is what we're going to use. We've got a pair of sides here. We got a pair of angles here. We got another pair of sides here. So we're ready to say that the triangles are congruent. And there's no figuring out on this problem what that statement is because it's right there. Triangle ABD is congruent to triangle CBD. And we'll put some arrows in there. And the reason is side, angle, side. And there is our complete proof. Now there is another way to organize your information when you're doing a proof, and that's called a two-column proof. And I'll show you what a two-column proof is here. And again, this is just another way to organize this information. I know some of you don't like doing flowcharts, and that's understandable. And some people just aren't comfortable with the format. There are other ways to do it. And one of those ways is called a two-column proof. And the two columns are titled statements and reasons. Now the statements always start with the stuff that is given. BD bisects AC. The reason is given. That was information that we were given. Okay. We also were told that the measure of angle ADB equals the measure of angle CDB. That was also given. That was here. Okay, now notice these statements are things that are inside the bubbles in our flowchart. And that's all these statements are. It's everything that you would put inside a bubble in a flowchart goes over here in the statement column. The next thing we ought to say is finish showing that the side angle side that's what we have in each triangle, side angle side. So next we would say AD equals CD. And the reason for that is right here. It's how we know that that's true, is the definition of bisect. Let's see, so we did the two givens, we did this one. Now we should do this one next. BD equals BD, and that is, the reason for that is shared side. Okay, now that we've got two pairs of sides and an angle, we're ready to say that the triangles are congruent. So triangle ABD is congruent to triangle CBD. And the reason is side, angle, side. And these proofs always end with what we are trying to prove. Here's what we're trying to prove. When we get there, we know we can stop. It's at the bottom of the flowchart. It's at the bottom of the two-column proof. That tells us when we are done. And so these are just two different ways to organize the information in proof. Here a flowchart, here a two-column proof. Okay, let's check out another one. Okay, you might recognize this shape here. The shape is called a parallelogram. The definition of a parallelogram is that it has opposite sides that are parallel, and that's what these arrows mean. We're going to try to prove that angle S equals angle W. And that might be something that you've been told is true in another class, in a previous class, but you've never actually proven before. And that's what we're going to do right now, is prove them. Okay, we're going to do a flow chart on this one. I'll do a two-column proof on the last one. Okay, these vertical lines right here, they mean parallel. So HS is parallel to WP. You already see that the symbols for that are already in the diagram. WH is parallel to PS. Again, those symbols are there too. But that's all that's given. Okay. Now, all of the proofs that you're going to be doing in this section are going to involve congruent triangles. So even if it doesn't ask us along the way to show that the triangles are congruent, like it doesn't ask us to show it, we're going to have to in order to get there anyway. So kind of a first mini step here is trying to figure out how we know these triangles are congruent. Well, since the top and the bottom are parallel, that means this angle and this angle are the same. Those are called alternate interior angles. We know that when lines are parallel, alternate interior angles are the same. So that's one thing we can figure out. Here we've got another pair of angles that are alternate interior, and they're the same because these two lines are parallel. Now they also share a side here. So that side is the same in each triangle. Oh, and look what we got here. We got angle, side, angle. Angle, side, angle. So those two triangles are congruent by angle, side, angle. So let's organize the information that we have here. So let's say HP equals H. Oops, I wrote B, sorry. P. And how do we know that? That is a shared side. Okay. We said these two angles were the same. That's, oops, measure of angle SHP. SHP, that's this one. And WPH, that's this one, equals the measure of angle WPH. I'm sorry, I'm going on kind of another line here, but I ran out of space. Now, how do we know those two angles are the same? Because alternate interior angles are equal. And I just abbreviated that there. Okay, now we know that angle SPH, that's this two-arc angle. Measure of angle SPH equals the measure of angle WHP. Measure of angle WHP. And again, those are equal because alternate interior angles are equal. Remember, we've got to justify each statement. Whether you're doing a flowchart or a two-column proof, we've got to justify each statement. And proofs should also start with what we're given. We've got to have that stuff in the proof as well. So let's see. These two angles are the one-arc angles. We needed the top and the bottom to be parallel. That's HS and WP. So we're going to put that here. HS is parallel to WP. And we used it to draw this conclusion. The reason we know it's true is called given, because we were given that information. WH is parallel to PS. That is given, and we used it to draw that conclusion, so we'll put an arrow there. Now, we've got everything we need for angle side angles, so we're ready to say that the triangles are congruent now. So let's call this triangle, I don't know, SHP. SHP. We're going to say that's congruent to triangle. Okay, so now I started with S. That's like W. H is a one-arc angle here, and P is the one-arc angle in this triangle, so P comes next. So WPH is the last one. Put an oval around it. We used all three of those statements to draw that conclusion. The reason is angle side angle, because we said angle side angle, angle side angle. Now this time we're not done. We're trying to prove that angle S is congruent to angle W. These angles are the same. Not that the triangles are congruent. Although we have to do this first, we're not done with our proof. There is one more step. You can say the measure of angle S equals the measure of angle W. Okay. Now, we just proved that these triangles were congruent. That means all of the corresponding sides and angles are congruent too. S and W are corresponding sides. That means they have to be the same. So the reason we're going to say here is congruent triangles have congruent parts. Again, that means congruent triangles have congruent parts. And that is our reasoning for this last one and our completed proof. Let's do one more proof. This time we'll do a two-column proof. So we'll need a statements column and a reasons column. Now these proofs, they always start with the given information. Always, always, always put that first. So measure of angle A equals measure of angle H, and MT equals ST. Those are the two things that we are given first. The reasons, since they are given, the reasons for those are given. And let's put those in the diagram too. Angle A equals angle H. And MT equals ST. Okay. Now, just like the previous one, even though we're not asked to prove the triangles are congruent, we have to. Okay. It's always an intermediate step, if not the end. So we've got to show these triangles are congruent first. So let's try to figure out how we're going to do that. Well, we can't do it by angle side. So hopefully there's one more thing here that we can figure out about these two triangles. And there is. You might notice it already, but there are some angles here that are the same. And those are called vertical angles. That's how we know they're the same. So our statement is going to be the measure of angle MTA equals the measure of angle STH. And the reason is vertical angles are equal. Now we have enough to say that these two triangles are congruent. So let's say triangle ATM is congruent to triangle. So I started with A, and that goes with H. And I went to T, that's T. And then M is S. And the reason is angle, angle, side. Angle, angle, side. Now we're not done. We haven't gotten to what we're trying to prove. We're trying to prove that these two sides, these two segments, are the same length. Now what we just proved is that these triangles are congruent. Now since the triangles are congruent, that means all the corresponding parts are too. That means these two angles are the same, these two segments are the same, and these two segments are the same too. So we have one more statement, AM equals HS. And our reason is the same one we ended with up here. Congruent triangles have congruent parts. And we are done again because we got to what we are trying to prove. Hope that makes sense. If not, get some more help in class. See you later. Bye.